Hey everyone, have you ever wondered how a poll can predict an entire election just by asking a couple thousand people? Or how companies know what millions of customers want? Well, it all starts with something called data collection and sampling. It's kind of like the first step on the path to any big discovery. So let's get into it.
And a very special welcome to all of you in mathematics in the modern world. I want you to get ready because today we are kicking off a real data adventure. Seriously, think of yourself as a detective. And data? Well, data is the set of clues you're going to use to crack the case. So, let's start hunting for some clues.
All right, first things first. What is data? You know, it's so easy to just picture a giant, boring spreadsheet full of numbers. But it's so much more than that. Really, data is just a collection of clues. Observations that, when you put them together, help you understand what's actually going on in the world.
Okay, so let's get our terms right, so we're all on the same page. Think of it like this. If you ask one person a question, their answer is a single data point. Now, if you collect a whole bunch of those answers, you've got yourself a data set. And the word data, that's just the general term for all these related clues you've gathered. See? Simple as that.
Now as a researcher, you hit your first big choice right away. Are you going to go out and gather your own clues? That's called primary data. So for example, creating your own survey for your classmates. Or are you going to use clues that somebody else already found? That's secondary data, like using numbers from the US Census. Both are super useful, they just have different jobs.
Okay, so this brings us to one of the biggest challenges in all of research. Let's say you want to know the favorite food of every single college student in the entire country. I mean, how on earth could you possibly ask every single one of them?
The honest answer? You can't. It's not possible. It would cost a fortune and take, well, forever. And that, right there, is the whole reason sampling exists. It's our way of finding a smart, reliable shortcut to get the answer without talking to everybody.
So let's break it down. The population is the whole world you're interested in, every single college student. The sample is like a small, really detailed map of that world. And your whole goal, your mission, is to draw a map that is so good, so representative, that it tells you what the entire world looks like.
And hey, speaking of community, I just want to hit pause for a second and give a massive shout out and thank you to everyone who subscribed to our class channel, No Problem, Only Solution. Seriously, your support is what makes it possible for us to create these explainers. And if you're new and this is helping you out, we'd love for you to join us.
All right, let's get back to our data adventure. So we know we need a sample, a small group to study. But how do we actually pick who's in that group? This is a huge deal. It's like a crossroads in your research, and you have to choose which of two very different paths you're going to take.
And here's the fundamental difference between those two paths. On one path, called probability or random sampling, every single person in your population has an equal chance of being picked. It's totally fair. On the other path, non-probability, they don't. The chances are not equal, and that one little difference changes everything.
So let's talk about that first path, the random one. This is what we call the gold standard in serious academic research. And why is that? Well, because randomness is your absolute best weapon against something called bias. It's what makes your results believable and trustworthy.
And there are a few cool ways to do this. Simple random is literally like a lottery draw. You put everyone's name in a hat and every single person has an equal shot. Systematic is a bit more orderly. You might line everyone up and pick, say, every 10th person on the list. And stratified is really clever. You divide your population into groups first, like freshmen and sophomores, and then you take a random sample from each group to make sure everyone's represented fairly. Let's look a little closer at how systematic sampling works, because it's pretty neat. First, you get a list of everyone. Then you do a quick calculation to figure out your interval, like I need to pick every 20th person. After that, you pick a random place to start, and then you just go down the list, picking every 20th name. It's a super straightforward and powerful way to stay random.
Okay, now for that other path, the non-random one. And I've got to say, while these techniques do get used sometimes, if you're doing serious academic work, you need to approach this path with a giant flashing sign that says, "Caution."
See, these methods aren't based on chance, they're based on the researcher's judgment. Convenient sampling is when you just survey your friends because, well, it's easy. Purposive is when you handpick people who fit a specific profile, like only talking to team captains. And quota sampling is deciding you need, say, 20 men and 20 women, and then just grabbing the first 20 of each you can find. You see the problem? Your own choices and biases can sneak in really, really easily.
And this quote really says it all. The reason non-random techniques aren't advisable is because of their biased nature. That bias directly attacks the reliability of your study. If your sample is biased, your conclusions are probably going to be wrong. It's a fundamental flaw that makes it really hard to trust the results.
So, we've looked at the map, we've seen the two paths. How do you take all this information and move forward on your own research journey? How do you make sure you end up with results you can be proud of?
Well, it really boils down to one word: transparency. You have to be crystal clear about what you did, who did you actually study, why did you pick them and not others, and exactly how did you do it. Documenting all of this is what builds trust and credibility. For your own work, this is absolutely crucial.
So, I'm going to leave you with this question to chew on. When you start your next project or your next big assignment, you're going to be standing at that same crossroads. So which path will you take? The easy one, the path of convenience, or the one that leads to findings that people can actually trust? That choice, it's going to make all the difference. And that's a wrap on our guide to sampling. I really hope this helps you get started on your own data adventures. And hey, to keep the learning going, make sure you check out the Beyond 2025 Math in the Modern World playlist we've put together. All of our explainers for the subject are right there waiting for you. Thanks so much for joining me.